Problem number 8 is a new set of problems where um, they want to know what's the equation of a line that represents something perpendicular to a given line. There's a given line. And that's not the only condition. Not only do you have to be perpendicular to that line, you have to pass through a point. You have to pass through that coordinate. And if we remember, coordinates are made up of an x and a y. An x and a y. And if we kind of go back to our memory from algebra, um, lines have a form. And yeah, this line's kind of got the form. It's got a y and an x in it, right? But usually we write lines as y equals mx plus b. And before I move on, I'm going to make a quick modification. You see how this equation has a y in it and an x in it? You all know the m. You know m represents slope, and that b represents the y-intercept, like the starting point. Um, x and y are directly related to that coordinate. Okay, so I'm just gonna kind of color coordinate my stuff. That y will be green, that x will be green, and I'm gonna make my slope blue. Right, and this is a true equation. I can feel safe in this. And whatever I know, I can substitute in and solve for what I don't know, what I'm looking for. So when we deal with perpendicular, we're really interested in slope, right? Because lines that are perpendicular, their slopes will be opposite reciprocals, right? So like if this line here had a slope of like 2/3, then the slope that's perpendicular, the slope that makes that right angle, the perpendicular slope, would be the opposite sign. So if the original is positive, the perpendicular has to be negative, and it's got to be the reciprocal. That fraction has got to be flipped. So instead of 2/3, it's going to be 3/2. And you put it all together, it'd be negative 3/2. So to figure out perpendicular, you got to know the slope, right? So um, this equation is 2y equals x plus 2. That's the line that they're starting off with. That's like this line. And in order to figure out the perpendicular one, we need to figure out the slope of that line. We need to solve this equation for y. So that's my first opening question, is like, how do I solve this for y? Well, I would simply divide both sides by 2. And I like to divide each term by 2. So I'll get y equals, there's like a hidden 1 here, so it's like 1/2 x, and 2/2 is 1. But honestly, I don't even really care about that. I'm just going to get rid of it. The important thing to know is my slope for that original line is that 1/2. Is that 1/2. So the line that's going to make a right angle, the line that will be perpendicular, it needs to be the opposite reciprocal of that slope. It's my perpendicular line. It's going to have a slope of, well, this one is positive, so this one's got to be the opposite sign, negative. And this one was 1/2. So this one needs to be that thing flipped. That 2's got to go on top, and that 1's got to go on the bottom. You could simplify that fraction as just -2, but why don't we just leave it as -2/1? Couldn't hurt. We can always revert back to -2 if we need. Okay? So now I know the slope that is perpendicular. I have that n value. So in this equation, that's the line I'm looking for. I can write a -2/1. I can kind of bring down everything else, that y, that x, and that plus b. Right? So I've done that perpendicular part. Now I need to handle with my line, this perpendicular line. It can't go through any point. It's gotta, like this line, when I'm figuring it out, it's gotta pass through the point 4, 3. Right? That line's gotta be on it. So this x needs to be in my equation, and this y, it needs to belong to the line. It needs to be on the line. It needs to be possessed by the equation. So I can use those values in my equation. So wherever I see a y, I can put 3. Wherever I see an x, I can put 4. And then if I bring down that slope, -2 over 1, I'm going to write 4 as a fraction. I can see I can solve for b. I can find my y-intercept. Because when you write a line, you really need to know these two things, the slope and the y-intercept. And we've got the slope, it's -2 over 1. We really need to know the y-intercept. So by using that x and the y, that's allowing us to solve for the only missing variable, that b. So when I simplify, I'm going to have 3, -2 times 4 is -8, 1 times 1 is 1, plus b, well, -8 divided by 1 is just -8. All right, I want to isolate my variable, solve for b, so I do the opposite. I've got to get rid of that -8. And if I do to one side, I've got to do to the other. 3 plus 8 is 11. Okay, so b equals 11. So now I know the two things I needed to know to write this equation. I've got my y-intercept and my slope. And I can just say, well, the line that's going to be perpendicular to this given one, well, it's going to be y equals -2x, so that's my slope, plus 11, because that's my y-intercept. Okay. You can stop here if you'd like. I can show you in GeoGebra that those things really are in fact perpendicular. So if I were to plug in my line, y equals -2x plus 11, let's see, y equals -2, oops, y equals -2x plus 11. It's going to graph a line. And the other line they gave me was 2y equals x plus 2. That right there, 2y equals x plus 2. Y. Oh, let's use the reduced form. Oh yeah, this one here. 1/2 x plus 1. Let's get that. Y equals 1 divided by 2x plus 1. If I were to graph that, those are the two lines. And if I were to kind of measure that angle, if I were to measure, well, we went the other way. If I were to measure that angle, you can see it really is a 90-degree angle. And we can double check. Does this line really pass through 4, 3? If I go back to that graph there, I can see the point 4, 3 is in fact right there. It does go through that point 4, 3. So I know this was a long one, but this was kind of like an instructional video. For the rest, I'll blaze through it and you can just kind of check your answer against the method in the final solution.